Okay, so let us continue with the discussion on the distance formula. Okay, so as we have presented in the first video, we have the formula for the distance formula. We have d is equal to square root of x sub 1 minus x sub 2 square plus y sub 1 minus y sub 2 square. Okay, so of course, x sub 1, x sub 2, y sub 1, y sub 2 are the coordinated points of each given point. Now, why is it that the computation, the how of computing the distance between 2 points has the form of this formula? Now, let us take note of that. Okay, so um, using this illustration, I will be illustrating how did we come about with the formula for the distance formula. Okay, so suppose you are given 2 points. One is at the origin, and the other one is at this point. And we draw an arrow pointing towards from the origin towards that point. So what we want is to to compute for the distance of this line. So in order to get the distance between these 2 points, between this point and this line in the origin, we need to specify the coordinated points of these 2 points. So the coordinated points of course, of the origin is 0, 0, and the coordinated points of this point at the tip of the red arrow is 3, positive 4. Both of these 2 points, 3 and 4, are positive since the point is obviously on the first quadrant. Okay, so of course, in terms of projected distances of this point in the x-axis and in the y-axis, this distance is actually the distance as represented by this green arrow, which is the distance along the x-axis, which is 3 units. Whereas this distance is actually the projected distance of the point on the y-axis, which has 4 units. So this means this point, which is 3, 4, the values 3 and 4 are actually the projected distances on x and on y, just like what we have presented in our definition of the Cartesian coordinate system. Now, looking at this in a different perspective, if you're going to draw the two vectors or the two lines, in this manner again. Okay, so drawing the two lines in such a way that they will be forming a right triangle. Of course, this if we're going to move this for example, this blue arrow in this side of the drawing, we will be having this right triangle as our figure, forming a right triangle. Now, taking note that in our right triangle here, this is actually a right triangle. So having the green arrow as the base and having the blue arrow as the as one of the sides or one of the legs of the triangle. Now, since this is a right triangle, try to recall our basic trigonometry, that for every right triangle, the length of the hypotenuse, which is labeled as c, the square of that is equal to the sum of the squares of the legs. So if we're going to label this as our A and this is our B, then A square is equal to B square is equal to C square, which is commonly known as the Pythagorean theorem. Now, of course, the length of the hypotenuse would be the distance, or our target distance between the 2 points, the origin and this point. So this means that the coordinated points, or the distance between the coordinated points, is simply given by the Pythagorean theorem. If you're going to look back at the formula for the For the distance formula, the distance, if we're going to extract the root here, this would serve as d square is equal to the difference between x sub 1 x sub 2 square plus y sub 1 minus y sub 2 square is actually of the form of the Pythagorean theorem, where d square is actually your square of the hypotenuse, y square is the square of your a, and x minus x sub 2 square is the square of your b, because x is your base and y is your height, and d would be the hypotenuse. So therefore, the distance formula is simply the application of the Pythagorean theorem, extending the Pythagorean theorem to coordinated points. Okay, so let's try to have a few examples. In this example, we are asked to plot the no. I'll be asking you to do these examples for points B, point C, and point R, and point W. Okay, I expect that you will be submitting this as part of your requirement. Okay, so let's have a few examples on distance formula. So in this example, we are asked to find the distance between the following points. So 1, -7, 3, -2. Let's have that example. Okay, so I haven't done this example, but okay, so I'll be doing the set of examples here in the figure with a triangle. And I'll be asking you to do the set of examples here, finding the distance between the following points instead, as part of your exercises. Okay, so I'll be doing this example for the distance formula. Okay, so what is asked here is that given the figure with the following coordinate points P, Q, R, we are asked to solve the length of the line segments PQ, PQ, QR, and PR. Now, the succeeding questions is triangle PQR an equilateral triangle? And letter C, is triangle PQR an isosceles triangle? Now, of course, the idea of having to answer question B and question C, we will not be able to answer whether the triangle is an equilateral triangle or an isosceles triangle, not unless we have solved the lengths of the line segments PQ, QR, and PR. Of course, an equilateral triangle is a triangle that has equal lengths of the sides of the triangle. So whatever this distance is actually this distance and this distance, and these three are of equal distances for an equilateral triangle. So therefore, in order to answer letter B, we need to solve for the distances between the pairwise line segment. The same goes with an isosceles triangle. In order to answer whether the triangle in the figure is an isosceles triangle, we need to solve for the distances between the line segments, or the distances of the line segments. And of course, in order to answer decide whether the triangle is an isosceles triangle, we need to know what is an isosceles triangle is. An isosceles triangle is a triangle that having two sides of equal lengths, and the other one is of a different length. So as opposed to an equilateral triangle, is a triangle having all sides of equal lengths. Okay, so let's try to answer this example using the distance formula. Okay, so this is the solution. First step in the solution is first determine the ordered pairs of the given points. So from the figure, point P has the coordinate points 2, 1, 2, 3, 4, 5 units for y, and 2 units for x. So point P is actually 2, 5. Point Q, on the other hand, has the distance 1, 2, -2, and 1, 2, +2 for Q. So -2, +2. And finally, r, you have 2 for as the distance on x and 0 for the distance on y. Y is 0. It is because the point r is actually entirely on the x-axis, so there is no elevation or measurement on the y-axis, so its y value is actually 0, so 2, 0. Now, given these coordinate points, we can now compute for the lengths of the line segments PQ, QR, and PR. Okay, so try to recall the formula: x sub 1 minus x sub 2, y sub 1 minus y sub 2. For the distance between PQ, that would be 2 minus negative 2, 5 minus 2. So 2 minus negative 2 would be 2 plus 2, or 4. 5 minus 2 would be 3. 4 square plus 3 square, it gives you 16 plus 9. 16 plus 9 would be 25. 25 square root of 25 would be 5. That means the distance between between P and Q is actually 5 units. Okay, so next is the line segment PR. So PR, P and R, so that would be 2 minus 2, 5 minus 0. Okay, so 2 minus 0 is 0, square is 0, 5 minus 0 is 5, 5 square is 25, square root of 25 gives you 5. So that means the line segment PR here is of 5 units. Next would be the line segment QR. So between QR, that would be negative 2 plus 2, 2 minus 0. Negative 2 plus 2 would be 0, 2 minus 0 would be 2. That means this leaves you square root of 2 square, or 2. So, having computed for the distances, we can now obviously answer the questions in B and question in C. So, is triangle PQR an equilateral triangle? The answer is obviously no. An equilateral triangle is a triangle with all three sides having equal lengths. Since the side PQ and PR are of equal distances, and the third side of the triangle is of a different length, therefore the triangle PQR is not an equilateral triangle. Is triangle PQR an isosceles triangle? The answer is yes. An isosceles triangle is a triangle with two of its sides having equal lengths and the third side of a different length. Line segment PQ and PR are of the same length. Two legs having equal lengths. QR on the other hand having a different length. So that is 2 out of 3 and 1 out of 3. Therefore, the triangle is actually an isosceles triangle. Okay, so let's have a different set of examples. For distance formula, solve for the equation of the circle in the following figure. Note that the line segment OQ is equal to the line segment OP. Why is it that we have this note of the line segment OQ being equal to the line segment OP? It is because for every circle, the distance of any point from the center of the circle is equal to the radius of the circle and is of equal distances at any given point for as long as it is the distance measured from the center of the circle. So this means this distance is actually equal to this distance. OQ is equal to OP. Okay, so let's do what is being asked. We are asked to solve for the equation of the circle. Okay, so using the distance formula, the distance OP given the